Let's go ahead and take a look at some more ways we can divide fractions. And so that common denominator approach usually surprises many people around um, dividing by fractions, and we're never taught that. So another way would be through the missing factor approach. The idea that if a divided by b equals something, right, then we know that b times that something has to equal a. Sorry, not c. Has to equal a. B times what equals a. It's the missing factor approach. So, for example, 9/10 divided by 3/5. That equals what, right? What does that equal to? Well, I don't know what that equals to, but I know that 3/5 times that thing has to be equal to 9/10. And I could easily see that. That'd be 3 times 3. So that answer is 3/2, because 3 times 3 is 9, 5 times 2 is 10. Got it. If 25/12 divided by 5/2, what does that equal to? Well, I don't know, but I know 5/2 times whatever that is has to equal 25/12. And so then that has to be equal 5 on the top, 6 on the bottom. Now, again, this only works if I can find a factor, right? I can find the numbers that multiply. Sometimes it doesn't always work that nicely, but again, it's a way to think about it. And many of our problems are kind of in that way, where they're common factors or multiples of each other, so it's easy to calculate. And here's another way that is often surprises many people. It's what we call the dividing across method. You get a chance, play this video by our favorite mathematician, right? Our math educator. And what we see is that we could just divide across, actually. A divided by B, sorry, A over B divided by C over D. Is that equal to A divided by C over B divided by D? So here's a question for you. We have 8/15, right, divided by 2/3. Well, the normal rule would be to flip the second one, right, and then multiply, get 24/30, which simplifies into 4/5. But the divide across rule, take a look. What's 8 divided by 2? 4. What's 15 divided by 3? 5. 4/5. Got it. It worked. Pause and be amazed. Pause and be amazed. Yeah. Pretty crazy, right? That works, and I didn't give you a heads up over here. It kind of works over here in these, as we've done these over here. You could see I've done one here earlier. You can just divide 5 divided by 2, 4 divided by 4, right? You get 5/2 over 1, 5/2, right? So the divide across actually works. Now, what happens on a more complex problem like this? 4/7 divided by 3/2. Okay, let's divide across. I get 4 divided by 3, 7 divided. It doesn't. They're not common factors, so I still get 4/3 divided by 7. Has nothing changed. Well, a trick you can do is back to common denominators. I could turn this into 8/14, and I could turn this into 21/14, and then divide across. So I get 8/21/14/14. That's 1. So now we have our answer, 8/21. So dividing across could work if we have common factors, or you put into a common denominator or common multiples in the denominator. So pause and take a look, but dividing across could work. And then the wonder play grow, you could fool around to see how you would solve them. I would use the reciprocal method for the first one. All right, I would do 17/4 times 11/4. That we'd probably have to do it that way. I don't see any way to get that one done, right? So you end up with 187/16. For this one here, maybe common denominator, I get 21/28, 20/28, and then I would get then this equals 21/20. Again, fractions are hard to conceptualize because I don't know what that really is. What is 21/20? Like there's no real world context. That's why this is kind of tough. This one I would divide across. So you get 3 over 5. That's it. That was an easy one. See, because you have the common factors and multiples here. 3 over, that's easy. Yeah, that one. And then your answer is 55 over 247. This one you just have to multiply. Reciprocal, nothing cancels. So that's what you would get. Lastly, to finish, we're going to talk about what's called complex fractions. And this is emerges when, and it happens a lot in an algebra class, and you can see the algebra notation over here. But notice the mathematics, like 3/4 divided by 1/3 comes from this situation. 3/4 of a liter, each small cup holds a third of a liter. How many cups can you fill? So that turns out to be a problem. 3/4 divided by 1/3. How many 1/3 fit into 3/4? And so then you get your 9/4. But notice the little mathematics trick here, or not trick, it's just mathematics. I'm multiplying the top and bottom fractions by the reciprocal of the denominator. That turns it into 1. Anything divided by 1 is whatever's on the numerator there is itself. So in this case, I end up with a multiplication problem that I can do 9/4. Here's the proof of it. Notice, and then notice this looks just like, right? This looks just like the formula we have for multiplication of fractions, because that's what it turns out to be. AD times BC. And so there's your final example there. 1/2 divided by 3/5. Multiply the top and bottom by the reciprocal or multiplicative inverse of the denominator. That becomes 1, 5, 6. Done. That's complex fractions. Again, I really like to highlight that one because it really helps us or helps students when we get into algebra. We do a lot of maneuvers like this in an algebra class.